All right, so we did a little bit yesterday, so I don't even know. Did I record yesterday's? I can't remember. Did I put it up on the thing? Yeah, I did. Okay, I do remember now. I don't know if I called it A or not, but anyway, I'm calling this one B because this is like the second part of it. The synthetic division that we did yesterday was pretty important for what we're going to do today because we are going to use it several times. So once we get to it, I know it's brand new for most of you. So I know you don't like have it down pat yet, but when we get to the point where we're doing it, you're going to see the more and more you do it, the easier and easier it gets. And it's really not that hard once you understand what's going on. Just like anything, I guess. All right, let's talk about this. I'm going to write down the remainder theorem, then I'm going to write down the factor theorem. And you're going to look at it and you're like, I have no idea what you're talking about. But then when we start doing some examples, we're going to look back on it like, oh, okay, I think I see what you're talking about now. Is that all right? So don't get all in a huff when you see this because it may not make a lot of sense when I first write it down. But then we do a couple examples. We're going to look back on it and you're like, okay, I think I see what we're doing. So let's do the remainder theorem first. When I talk about remainder, I'm talking about doing division, right? Like we did yesterday and having a remainder in the division problem. So that's what remainder that I'm talking about. All right, so the remainder theorem. They're kind of intertwined, these two, the remainder and factor theorem. They got some slight differences. So here we go. It says, if a polynomial, I don't usually like write out definitions like this all the time, but I think this one is important to do. And we're going to call that polynomial f of x. All right, it's just going to be some kind of, it could be x squared plus 2x plus 3. It could be x to the fifth plus 3x to the fourth minus 2x third. You know, that's what I'm talking about, a polynomial. All right, and we're going to call it f of x. If that polynomial is divided by x minus k. I think yesterday I used r. I couldn't remember what letter that I used. Some people use different letters. Some people say x minus a. Some people say x minus b, whatever. But right now they're using x minus k. I think I used r yesterday. So we did talk about a remainder, and I think I used r because of remainder. It says the remainder is f of k. Now again, I understand you don't really know what's going on. Remember we did that long division? Don't write this part that I'm going to write here. I'm just going off the cuff here, all right? So remember this, and you said like x minus 3 divided by like x cubed minus 2x squared plus 4x minus 3. Remember that? Okay, we did something like that yesterday, correct? So what does this say? If the polynomial, which one's the polynomial that they're talking about? This. If it's divided by x minus k, what's my x minus k? It's that thing right there. Then the remainder, so if I do all this work, all this work, and I get some remainder, okay? I don't know what the remainder is, but I get some remainder. We'll call it, I can't call it k. But if I get a remainder, it says the remainder is f of k. What does that mean? So whatever my remainder is, I'm just making up a number, okay? This again, all off the cuff. Let's say my remainder is 2, okay? What does that mean? The remainder is f of k. So this remainder is, if I put, let's see, if the polynomial is divided by x minus k, the remainder is f of k. That means if I put, hold on, let me think. If I put in, yeah, here's my k. So what is my k in this situation? If this is x minus k, what's my k? 3, agreed? Because it's x minus whatever the k is, all right? So it says the remainder, this thing right here, is f of k. So that means if I put a 3 into this polynomial, it's going to equal the remainder. All right, I'll do an example that actually works out. These are just made up numbers. But that's basically what they're saying, all right? You'll see when we do the example, it'll make a lot more sense. So now that's the remainder theorem. Now we're going to do a thing called the factor theorem. And it's going to look just as crazy. It says the polynomial x minus k, all right? So they're still talking about that because this is a polynomial as well, right? That big long thing was a polynomial. This is also a polynomial. So this thing right here, x minus k, is a factor. Now that's what we're really going to be concerned about in these homework problems is the factor part, okay? The factor theorem. So the polynomial is a factor of this polynomial. It's a different polynomial of the polynomial f of x if and only if and only if, oops, I put two F's there because in college when it was if and only if, instead of writing all that out right there, I'll just put it in parentheses, they put IFF. That means, that's like a shortcut of saying if and only if, all right? And I put two F's there because I was thinking of that. If and only if f of k is 0. We're going to come back to this, look at it after we do the example, and hopefully it might make a little bit more sense to you. So what we're going to do is we're going to do an example. But you got that written down, so I want to look at it, I want to refer back to it, and hopefully it'll make a little sense. So here's an example. We're going to say, here's my f of x, and now I'm not making this one up. This one's actually, it's not actually in the book. I found this somewhere else, because I'll tell you what, I looked at the book and their explanation, and it was a mess. It was crazy. So I was like, I got to find some better explanations. So, of course, where do I go? My favorite place, YouTube. Go to YouTube. It's not even Khan Academy. I did go there. He was a little bit too talkative, but I found this one guy. He hasn't put out videos in a really long time, but he's got thousands of of views and subscribers and stuff. But he explained it the best that I saw anybody else explain it. So I'm kind of using his way of explaining it. All right. So this is the factor, and what we're going to do, or that's the polynomial. So the question is going to be, is x minus 1 a factor of this thing right here? So let's go back to that factor theorem. What's it say? It says x minus k is a factor of this, so this x minus 1 is a factor of this if and only if, what? F of k, what's my k? We did this once before. What's the k? Remember, x minus k is, this is x minus what? So what's my k? We're not seeing this, are we? I'm not sure how best to explain it. Look, if I say x minus k, and then I said x minus 1, what's the k? It's not negative 1. It's just 1. It's just a 1. Everybody see that? All right, so it's x minus, there's x minus, what is the k? The k is a 1. If it was negative 1, then this would be x minus negative 1, which would be x plus 1, okay? So the k is 1, would you agree? So right here, what is the k? It's 1. So what does our theorem say? The question says, is this a factor? This says it is a factor if what? F of k is 0. So that means, what am I going to do? I'm going to go f of what? 1. That's right. So if I take this part right here and I plug it in for the x's in that long polynomial right there, if it comes out to be a 0, that means that x minus 1 is a factor of this long polynomial. What does that mean to be a factor? It means it's being multiplied by it, correct? Does that make any sense? So that's what that theorem says. So if they give you the x minus k, we can look to see what the k is. It's a 1. And the theorem says if f of k is equal to 0, then x minus 1 is a factor of this. It's evenly divisible by x minus 1. Right? If something is evenly divisible, what's our remainder? Our remainder is always what? 0. Okay? Does that make sense? All right, so let's put it in here. Let's see if it comes out to be a 0. So it's 2 times what? 1 cubed minus 3 times 1 what? Squared minus 5 times 1 plus 6. Let's do this. That's a 1, so that's a 2. What's that? Just minus 3 minus 5 plus 6. What do we get? Hold up. Did I do that right? Yeah, I did that right. Negative 1. Oh, yeah. Oh, for some reason, I was thinking in my head, 2 minus 3 was 5. And it's not 5. That's what. A simple little mistake. So 2 minus 3 is what? Negative 1 minus 5 is negative 6. Negative 6 plus 6 is what? Is 0. Whew. Just a simple little dumb mistake. And it is 0. So guess what? What did I just find out? By me putting that number in for this and getting a 0, what does that mean? That means what? X minus 1 is a factor. So yes. Okay, I'll put a yes right here. And I'm excited, so I'll put an exclamation point. Okay, so yes, x minus 1 is a factor. So that's all they ask you right there. Now they're going to ask you a little bit more than that, but that's what they're asking. Everybody okay with that? That wasn't hard, right? It's just substitution, right? You take that number, you find what k is, which isn't really that hard to find, and then you just throw it in for the x. And if it comes out 0, you know that x minus 1 is a factor, okay? Remember what I said before. If x minus 1 is a factor, that means it's evenly divisible. That means if I go 2x cubed minus 3x squared minus 5x plus 6, and if I divide it by x minus 1, what's my remainder going to be? It's going to be 0. I see Abby back there going like this, okay? 0. So guess what we're going to do? This is another way to do it. This is method 1. Okay? We're going to kind of do it another way. We're going to go to method 2. And this kind of is the remainder, it is. The remainder theorem. Let's look at the remainder theorem. Look, if a polynomial is divided by x minus k, so what's our polynomial? This thing right here. Everybody see that? If that polynomial, if that polynomial right there is divided by x minus k, what's the remainder going to be? F of k. Well, we just found f of k, didn't we? What is f of k? It's 0. So if I take this, 2x cubed minus 3x squared minus 5x plus 6, if I take that divided by x minus 1, what should my remainder be after I do that division? Should be 0. Let's see if it is. Okay? And we're going to do it by synthetic division. I've watched a lot of videos on this, and some people, actually Khan does. Khan Academy, he actually does long division. All right? I don't know why he doesn't go to synthetic, but synthetic is way easier. Actually, let's put it right here so I can write the synthetic division. Now, here's what we do. For synthetic division, we always put the k right here. X minus whatever the k is. So what is our k? It's a 1. Even though we're dividing by x minus 1, we don't put a minus 1 here. Everybody see this? This is super important. What if? It's not, but what if it was x plus 1? What would you put here? A negative 1. Because what's x plus 1? It's x minus what? Negative 1. So what are you subtracting from the x? A 1, right? If it was, it's not, but what if it was x plus 1? Then you'd put a negative 1. It's just the opposite sign. Just think of it that way, okay? But I always like, sometimes if you just think, oh, it's always the opposite or always the same, it doesn't make sense. But this is x minus k, so what's my k? My k is 1, so I put a 1 there. Everybody with me? Now, what do I put next to it? All the stuff that I'm dividing. What am I dividing? Or what's my coefficients? It's 2, and then always take the sign in front of it. super important. It's negative 3. Then what is it? Negative 5, and then 6. So what are we doing? We are trying to do a division here, all right, and see if it comes out with the same remainder as when we plug that 1 in for that polynomial. Yes? All right. I know it's a little confusing. But after you do it for a while, you're like, okay, I think it's coming together now. Remember what we do? I know we've only done one of these, but do you remember? Maybe flip back in your notes and see what our first step was. Well, not yet. We got to do something first. Drop it down, okay? I'm going to drop this down, all right, and just keep it exactly the same. Now, Sam, what do? Now I multiply. So it's 1 times 2, which is 2, and I put it right here in that spot. All right? That's why I left a little blank before I put that line there, because I'm going to put some numbers in here. Now, what do I do with these two columns right here? I add them up. So negative 3 plus 2 is negative 1. And now we just repeat the same thing. Okay? It's really pretty easy once you get the hang of it. Now I go 1 times negative 1 is negative 1, and I put it right here. What do I do to these two? Add them up. Negative 5 plus negative 1 is negative 6. Now what do? 1 times negative 6 is negative 6. What do I do with these two? Add them up, and I get 0. And that's what I was supposed to get, isn't it? Okay? I was supposed to get a 0. You okay with that? I'm going to take this a little bit further. Okay, so now I know by doing this and getting a 0 there, what did that tell me? What did this tell me? That told me that x minus 1 is a what? Is a factor of that whole entire polynomial. Okay? That means it's evenly divisible by x minus 1. Okay, so if I take that whole entire polynomial that we started with, this thing right here, I should be able, not should, I can divide by x minus 1. So guess what we're going to do right now? We're going to take that, well, actually, did we already do it? Yeah. We're going to find out what's left over after we do the division. Okay, we did the division right here. All right, so what are we going to do? This is my what? My remainder. I always go this way. A lot of people do this. Since you started off with an x cubed, almost every video I saw said, oh, well, this is going to be 1 less than that first power. Okay, so what's 1 less than x cubed? X squared, right? I don't like to do that. I like to start from the right and go to the left. Especially if you have a whole bunch of them. I mean, because you could have like 5 or 6 different terms here, okay? I always like to start with this one. This is my remainder. What's this one? This is my constant. Then just work our way up, okay? So instead of descending order, it's what? Ascending order, right? From right to left. So what's this? This is my x term, and what's this one? This is my x squared term. So let's write it. So what we just showed right here, if it's a factor, then x minus 1 times this stuff right here is going to equal that original polynomial. So what is this? This is going to be 2x squared, right? Minus x minus 6. Remainder 0, so I don't have to worry about it. So this right here equals that original polynomial. 2x cubed minus 3x squared minus 5x plus 6. You with me on that? All right. I think we're getting somewhere, don't you? But guess what they're going to ask you to do? They don't want to know just, well, like on that one problem, yeah, they're fine just knowing one factor, okay? Or knowing if it's the factor to begin with. But they're going to go a little bit further. That was just the baby step. We're taking little steps forward now. So we know that x minus 1 is a factor, and we know what's left over after we factor it out, right? After we divide it out, this is what's going to be left over, correct? So what do you think we're going to do with this? We're going to factor that, exactly, okay? So what I want to do is I want to find all the factors of this crazy polynomial, 2x cubed, because we haven't done that yet. The only thing we've factored up to this point are what? Just squareds, right? Quadratics. That's the only thing we factored so far, just quadratics. Or maybe there was an x cubed, but there was a common factor that you could factor out of it. all right? But we haven't done anything like this. So this is like a landmark thing that we're able to do now. Okay, we don't just know how to factor quadratics. Now we can factor all kinds of crazy looking polynomials by using this method, all right? So now, what do we do here? You could factor this a couple different ways. I'm going to, since I already know what it is and I'm running out of time, I'm just going to put it in here, all right? So I'm going to put, thank you. Basically, I'm just doing guess and check, all right? You could go that thing, remember that thing where you go 2 times -6, you do all that stuff. You could do that and it'll work, it's fine. But in this situation, I think I'm just going to go this. So this times this has to be 2x squared. So if that's 2x, what are we going to make that? 6. Now, this last one right here and this last one has to multiply to be -6. So you've got several different choices. You got 1 times 6, right? You got 2 times 3. You got 3 times 2. Then you can switch the order. So there could possibly be a lot of guessing on this. But eventually, you'd run out of options and you'd get it right. So I'm just going to guess right the first time, okay? I know that's terrible teaching, but that's what it is. Now, let's just see it. Everybody understand? I might not, I got it right in front of me, so I knew what it was. But I could have just guessed a whole bunch of things. I might have got it wrong. I might have put the 2 here and the 3 here. I might have put a 1 here and a 6 here, right? You just keep going until you get it right. How do you know if you get it right? Well, when what? The outside and the inside add up to what? -1. -1. All right, so does that work here? 2x times -2 is -4, right? Plus 3, -4 plus 3 is -1. Yep, it works. Okay? So I kind of skipped a little bit. I just skipped some of the work. Okay, sometimes you might have to put in the work. All right, but there it is right there. So check it out. What did we just do? We found the factors of that big old polynomial. I'll write it down instead of scrolling up. Just put it right there. Thank you. So I found the factors of this big old polynomial. I said it enough. I should have it memorized, but I don't. Okay. So do you see this right here? All this is equal to this. And I factored it. You got it? Now, what else could we do with this? Remember, this was originally equal to what? Or if it was an equation, it was equal to what? 0. So this would have all been equal to 0, correct? So let's actually solve for x. So we're finding the roots, right? Finding the solution for x. We want to find x if that thing was equal to 0. So if this is equal to 0, what can we do with this? Set x minus 1 equal to 0. Set 2x plus 3 equal to 0. And then set the x minus 2 equal to 0. Let's do the math. Very easy. Add a 1, x equals 1. Subtract a 3, divide by 2. What's that? Subtract a 3, divide by 2, it's -3/2. Add a 2 to both sides. Oops. Add a 2 to both sides and you just get 2. So look at this. If I set that equal to 0 to begin with, these are my solutions for x. If you wanted to, you could plug them in and see if it works. We already plugged the 1 in, remember earlier, to see if x minus 1 was a factor. So we know that came out to 0. Let's plug a 2 in just for fun. All right? So what's this going to be? 2 cubed is what? 2 cubed. 2 times 2 times 2. What's that? It's 8. Thank you. You awake? So what's 2 times 8? 16. Minus. Put a 2 in for this. 2 squared is 4. Minus 12. Good. Put a 2 in for this. Minus 10. And then plus 6. Does that work? That's 4. 4 minus 10 is -6. -6 plus 6 is what? 0. So that does work. This would be a pain in the butt, wouldn't it, to put a -3/2 in there? Not going to do it. But what do you think? It's going to make it a 0. Exactly right. Okay? So all 3 of those are your solutions for this polynomial. And we use the remainder theorem combined with the factor theorem to come up with our solution. Pretty crazy, huh? Now, if you wanted to graph it, now this, I mean, look, could you graph that by hand? Well, you wouldn't be able to do it probably perfectly, but you could get some kind of an idea of what it looks like. Remember, do you remember the end behavior stuff that we did? If it was a cube. Remember it was just x cubed. What did it look like when it was x cubed? One went up like this, one went down like this. So this is kind of do the same thing, right? So we'll do that. We'll do it in a second. But watch this. If I want to do just a rough sketch, this is just a rough sketch of the graph of this. What do you got? You got a 1 right here. You got a 2 right here. You got a -1 here and a -2 here. So where does it cross the x-axis? Well, it crosses at 1. It crosses at x equals 2. Where else does it cross? -3 halves, what's that? Negative what? 1.5. Crosses right there. Everybody with me on that? So what's the end behavior look like? Well, the end behavior starts down here, and what's it going to do? It's going to go up here like this, and then what's it going to eventually do? It's going to go up to some certain height. Again, this is rough sketch, then it's going to come back here like this. Then what's it going to do? It's going to go down here for a little bit. Whoops, I didn't do that very well. All right, it comes down here for a little bit, and it goes up here for a little bit. That's a very rough sketch of what that is going to look like. All right, I don't think they ask you, at least on the homeworks that I've assigned, they don't ask you to graph it, but it's good for us to see. All right, so you could have always gone to Desmos and graphed it and found out where it crosses the x-axis, and those would be your solutions. See how it's all coming together? For some of you, like, man, it fell apart a long time ago. It doesn't feel like it's coming together. All right, but I think it is. I think some of you, I see some nods. Maybe you're just being polite to me. I don't know. But I think it's starting to come together a little bit on what we're doing here. All right, I got 5 minutes. Let's do an example like you're going to see in the book. I actually probably went a little bit further than what the book is going to ask you to do. All right, so let's see what example I want to do, because I know I skipped an example. It's example 5. Let me see. Yeah, the example 2 was that synthetic division. Come on, don't lose me now. I got 5 minutes. I'm going to skip example 1. So let's go to 3. All right, let's go to example 3. This is in the book. It says, this looks almost identical to it, but it just says, here's a polynomial. You writing this down? Here's a polynomial. It's different than the one we just did. The question is, it says, use the remainder theorem to find the remainder when this is divided by x minus 1. All right, so I want to find the remainder. There's 2 ways to do it. One, you could do synthetic division. All right, and then another way, you could just plug in that k in for x and see if it equals what? 0. All right, if it equals 0, then x minus 1 is a factor. So that's the question they asked. I didn't write it down, but they ask, is this thing a factor of this? All right, so what do you want to do first? Let's do method 1 by just taking f of what? F of 1. Remember, this is f of x. Everybody with me? Super easy, right? Just plugs 1 in to this. So 1 cubed is 1 times 2. That's a 1 minus 3 plus 1. So what do we get? Negative 1 plus 1, which is 0. So is x minus 1 a factor? It is. Kiki, you just came in. All right, so you need to pay attention because you missed a lot of this. So pay attention to what I'm doing. So is x minus 1 a factor? Yeah, just from this, that's a factor. Really, that's all you need to do. But you could do it another way. You could do method 2 because sometimes you want to completely factor this. All right? So how are we going to do that? We do synthetic division. We put the k right here. What's the k? It's the same thing as we did on the example. What is it? It's just a 1. Then we put our coefficients. So we got 2, we got negative 3, We got 1, and that's all we need. There's nothing else after that. So let's do this real quick. This is good for us to remember. Bring down the 2. 1 times 2. Add them up is -1. Multiply -1. Add them up, 0. So what does that tell you right there? That tells you that it's a factor, okay? That it's evenly divisible, right? So that's a factor. So both of these things are telling you the same thing, right? It's just two different ways to tell you the same thing. That yes, the question is this a factor? What's your answer? Yes, it's a factor. That's what I would do. Sam?
Do we have to do both methods?
You don't. You don't. I'm just showing you both ways, okay? But there are times, though, when you actually want to find the factors, because they just stop right there. Is it a factor? They might say, find the zeros, right? Find what x is equal to. So you will have to do it, because what's our factors? X minus 1 and what's this? This is our remainder. That's our constant. That's our what? That's our x. So what is this? It's 2x what? Minus 1. So if you multiply those together, that would equal this thing right here. So those are your factors. I could ask you just to factor this. Okay, if I ask you to factor this, right? Now, there's something else we got to get to that we didn't have time. But right now, they're making it easy for you because they're giving you options, right? They're saying, is that a factor? What do you think they're going to eventually do? They're going to give you something like this. Hang on just a second, okay? I'll dismiss you when I'm ready. Okay, this right here, they're going to say eventually just to factor it. And you have to figure out what is a factor. It's not always going to be x minus 1, all right? It could be something else. And there's a way to do that, and we're going to talk about that the next time. Still didn't dismiss you, and you guys are leaving. Be nice if you say, Mr. Hamrick, can we go now? Hold on. Did I give you any homework? See, everybody's leaving, and you're not even going to hear if we got homework or not. Just because you didn't hear doesn't mean we don't have any. And I did not write it down. So, let's see. 14 to 25. You may not be able to do all of them, but you should be able to do quite a few of them. 14, what did I say? To 25. Section 4.3. Do as many of those as you can. I think a lot of those are synthetic division, so you should be able to do a lot of those. And then some of them are, is this thing a factor or not? All right? So 14 to 25, section 4.3.